And lastly, vulnerabilities have value in an above-ground economy. If a researcher can get $10,000 from iDefense, you know, $10,000 from iDefense, attribution in a bulletin from Microsoft. Let me see. Depends on where they are. So enough about background. Now let's move on and talk about the holistic approach. So how is Microsoft in this changed environment with heightened threats and with more attacks? What are we actually doing? How are we approaching this problem? First thing I'll highlight is that individual efforts, like on IS6 or and uncoordinated attempts, uncoordinated efforts, are insufficient in this changed environment. It really requires a coordinated and a coordinated approach. This is a slide that I actually took from a marketing deck, so you know, sorry about the pretty graphics. I put this in though because I wanted to highlight that at the corporate level, at the Microsoft corporate level, we do have a framework for how we approach the security challenges. And that is, you can read the vision there. It's a secure platform with guidance to help keep customers safe. And really there are three primary pillars there. We make investments in technology. We make investments, prescriptive guidance is another key element, and industry partnership. So that's at the Microsoft corporate level. For us, at the security engineering and community level though, the way that we're actually delivering the results in the products and in the company is that there's a centralized team that is responsible for, one team that is responsible for defining what the policy is with respect to engineering standards and with respect to response. And that team is also responsible not just for defining the policy, but also for enforcing the policy and for validating that in fact teams have met those. Security development lifecycle is one aspect. The security engineering code, that's the SDL in practice. And then penetration testing to do enforcement of the standards. Emergency response, both on a regular monthly basis as well as on an emergency incident response basis. And then community outreach, because it is key to connect with the security research community. So SecD, Security Engineering Community Department, uses the same framework. Technology investments, prescriptive guidance, and industry partnership. So I've got much more specifics on this slide about what some of those kinds of things are. In terms of technology investments, /GS for the compiler or PatchGuard, some of the heap mitigations, analysis tools and fuzzing tools. Prescriptive guidance. You know, the security bulletin that comes out on a monthly basis, that is a form of prescriptive guidance that we deliver. The SDL, either the book that was just published through Microsoft Press or articles on MSDN. Conference presentations like these are a form of prescriptive guidance. You know, Window Snyder a couple of years ago said to me, I don't understand why it is that you've got guys like Matt Conover who are giving talks on the Windows Vista or the Windows heap. Why is it that you don't have a Microsoft engineer up there giving that talk? And it's out of that now we have a strategy and a program where engineers from the product teams are giving talks that are focused, that are not talks that they would give at Tech Ed or at the PDC, but these are really talks that are focused specifically on the security research community. Industry partnerships, conference co-sponsorship is an example of that, or collaboration with CERTs or other governmental organizations on, as well as some of the other alliances that we've formed. And honestly, BlackHat, I don't know whether you guys have heard about BlackHat or not, but that's a conference, a security conference that we put on internally at Microsoft. That again is another form of partnership with the community. So I've given you the framework. I've talked a little bit about the vision, where the vision really for the security engineering group is to embed that culture of security, both within the product teams and within the products. I want to start talking at this point about the security development lifecycle. As you can see from the slide, it is an end-to-end process. It starts at the beginning with defining security requirements, and then there are milestones along the way for threat modeling or for penetration testing, as well as the key element here is the final security review. There are all products that must pass a final security review in order to ship. One of the key differences from how we build products today versus how we built products back in the day was that it used to be that you would write code, you'd design features, you'd write code, you'd test it, and then you'd release to manufacturing, RTM. And after RTM, you were pretty much done with the product. You moved on. The big change with SDL is that we recognize that delivering safety to customers continues long after release to manufacturing. I've got two slides on SDL. One is so that you can see that it's an end-to-end process, beginning pass to RTM. And the second one is so that you can actually see that this is that it's a closed feedback loop. I also want to highlight here that the blue on the outer side that was how we did products normally. You know, you'd go, you'd get an idea, you'd create a spec, do some development work, some testing, a couple of milestones along the way, beta testing. SDL doesn't fundamentally change those milestones or how engineering teams go about their work. It does fundamentally change the specifics of how we work and the output and the deliverables. So we took the security milestones from SDL and aligned them with existing milestones, so that you can see that security testing is included with internal testing. I will highlight one other key aspect of the SDL, which is process, education, and accountability are key elements, the fundamental elements of SDL. It defines a process that is company-wide, standards for which compiler you use or how you track bugs, how threat models should be written. There's education as well, and education is actually a key piece of this, because what we really need developers to do is to internalize the need for security. Mandates only go so far. The other key aspect of SDL is that there is accountability built right in, so that individuals have to go and accountability is built in how we actually measure and track security on an ongoing basis, whether that's from training or whether it's automated tools that actually determine which compiler version was used, or whether threat models were actually written. So I just want to highlight that it really is a closed feedback loop. SDL is not a crap circle like some of these. I mean, deploy, update, support, terminate, and back to deploy, that doesn't really make a lot of sense, right? Or from conception all the way through to maturity phase and then back to conception, you know, not so much. But you can see that with SDL, it really is. From incident response and the security and the learnings from the Security Response Center, we actually take that, we do root cause analysis on every single one of those vulnerabilities, and we then feed that back into our development processes about what went wrong and how do we avoid this in the future. We've got automated code analysis tools or other automation. What wasn't there? How did we miss this one? So SDL applies across all divisions at Microsoft and across all businesses. As I mentioned, it defines the incident response as well as the update requirements. So if you think back to a couple of years ago, there were any number of times where patches didn't install, or you couldn't use deployment tools, MBSA wasn't always correct. The Microsoft Security Response Center defines those standards and enforces them across the board in terms of timeliness and completeness and quality. We have another team called the Secure Windows Initiative that does that as well on the engineering side, that defines them and then validates them. But SDL is not a one-size-fits-all. As I mentioned, you know, a mandate isn't going to actually deliver more secure products. A mandate will deliver a checklist that's completed, and it might also teach people how to actually game a system. But success really depends upon internalizing the learnings. And so the final product security profile is really each team takes the SDL and then also takes their own requirements, whether these are performance requirements or customer requirements or deployment requirements, and combines them and delivers a quality that a product that meets the bar for usability as well as for security. And as I mentioned before, the key aspect to SDL is that every product must pass a final security review. And there is a team of passionate engineers who actually do penetration testing. They'll review threat models. They'll actually then come in and do code audits and feature reviews. And if there's a problem, the report that goes back to the teams is, here's a problem that prevents you from shipping. You should go back and correct that problem, and then come back and reapply. And this is actually the biggest single change at Microsoft, because it was always features first. And if you know, I'll just take IIS as an example of this. With IIS 5, everything was turned on by default, because the way employees got rewarded was by writing code and then seeing their code ship. And of course, well, you want it to ship, but you also want it to be turned on so that you can tell your mom how to go do internet printing